Hello everyone, welcome to this video explanation brought to you by Morphverse. We're a dynamic team consisting of Team Lead Vansh Waze, Team Members Mandar Salvi Soham, Rane Vivek Rajak. In this video, we'll walk through the process of building an analytics module using Langflow and DataStax to analyze social media engagement data. Let's dive into the workflow step by step. Part 1, Text Data Processing and Storage Workflow. Step 1, File Input. We begin with the file component, where a dataset named Engagement Data 50 CSV is uploaded. This serves as the foundation of our workflow, providing raw data for further processing. The output from this module feeds directly into the next step. Step 2, Split Text. Next, we use the split text module to break the data into smaller, manageable chunks. Chunk size 1000 characters. Chunk overlap 200 characters to maintain contextual continuity. Separator left blank for default splitting, typically based on white space. The output is a series of well-structured text chunks ready for embedding. Step 3, Embedding text with Google Generative AI. We then pass these text chunks to the Google Generative AI module to generate embeddings, API key used for secure access to Google AI services, model name, models/text/embedding/004, which transforms the text into vector representations, capturing semantic meaning. These embeddings are now prepared for efficient storage and future retrieval. Step 4, Vector Database with Astra DB. Finally, we store the embeddings in Astra DB, a powerful vector database. Astra DB application token authenticates the connection. Database Morphverse VW. Collection Data. Ingest data connects embeddings to Astra DB for similarity searches and retrieval tasks. This completes the first part of the workflow, setting up a seamless pipeline from raw data to embedding storage. Part 2, Real-time query and response workflow. Step 1, Chat input. The second part begins with the chat input module, where users can interact in real time. For instance, a query like "What is the document about?" is passed into the system for processing. Step 2, Google Generative AI for embeddings. The user's input is then processed by the Google Generative AI Embeddings module. API key enables access. Model name model/text/embedding/004. This converts a query into an embedding vector, enabling semantic matching against stored data. Step 3, Astra DB for retrieval. Next, the query embeddings are matched against the stored embeddings in Astra DB. Astra DB application token ensures secure access. Database Morphverse VW. Collection Data. The most relevant results are retrieved and sent to the next module. Step 4, Parse data. The retrieved results are converted into plain text by the parse data module. Template field structures the output, though no template is configured in the screenshot. This prepares the information for the next step. Step 5, Prompt. We use the prompt module to create a structured query for the AI. Template. For instance, given the context about retrieved data, answer the following question: user's query. This dynamic prompt is then passed to Google Generative AI. Step 6, Google Generative AI for response generation. The structured prompt is processed by Google Generative AI model Gemini-1.5-Pro. Temperature set to 0.1 for deterministic responses. Output tokens controls response length. The output is a well-crafted answer to the user's query. Step 7, Chat output. Finally, the generated response is displayed to the user through the chat output module. This completes a real-time interaction flow. Conclusion: this project showcases a Langflow workflow designed for a social media analyzer. DataStax Astra DB was utilized to store and query vectorized social media data efficiently, enabling fast and accurate retrieval. GPT-based generative AI was leveraged to analyze the data and generate meaningful insights dynamically. This streamlined approach highlights the power of integrating modern AI tools with scalable databases for real-time social media analysis. Thank you for watching. Bye Team Morphverse.